Hello, everyone, and welcome to another episode of What's New in Prisma, the release 4.4.0. My name is Alex, and I'm a developer advocate on the Prisma developer advocacy team. And today I am joined by my colleague, Niko. Colleague or boss? I'm not sure what to refer.
Let's just stick to colleague for this stream.
Okay, no problem. Yeah, how are you, Niko?
I'm doing great, Alex. It's a somewhat sunny day here in Berlin. I've been to the office once this week and met our fellow developer advocate Tassin there as well, who some of the viewers might have seen in previous episodes, and who recently moved to Berlin as well. So we're now 3 developer advocates who are actually over here in Berlin, and I find that pretty exciting.
Indeed, 3 and counting. Let's just keep it at that, 3 and counting. Yeah, well, someone promised me, his name rhymes with Nicholas, that there'll be a golden October. It will be my first autumn, because in Kenya, we don't really have the concept of seasons per se. It's just either rainy or sunny. So I'm really excited to see what autumn will be like. Well, the leaves are already golden.
The golden October days here in Berlin can really be beautiful indeed.
Okay.
You have mild temperatures, you have beautiful colors outside. I'm looking forward to that.
Okay, well, I hope it's better than this week's temperatures, because I have been freezing indeed. Anywho.
All right. I also see Sabin in the chat, by the way, and that's a little bit surprising. That's another colleague of ours, another developer advocate, and I think he is actually giving a talk a recorded talk at GraphQL Conf, which I think is happening right now. So people will have to decide: do they watch our stream or do they watch Sabin's talk? I think that's the case. I might be wrong, but I think it's in parallel.
Indeed. Well, since we are already on the stream, we'd encourage you to stay on the stream, because we have we're going to showcase a lot of features. Well, a lot of whatever we released in the last sprint. And on today's agenda, we will be walking through the release notes, covering the different bugs and fixes and improvements that we made in the last 4 weeks. We will also have a guest on the stream who's a longtime friend of Prisma, talking about preview databases, and that will be Peter. And then after that, we'll be talking about the Prisma data proxy, what it is, why you should use it, and how to use it, or when to use it. And then after that, we'll talk about one of the article series that I've been working on improving query performance with database indexes. It's still a work in progress. We've released 2 parts out of, well, that's indefinite for the moment, so stay tuned. And then after that, we'll go over some Q&A. If you have any questions, feel free to post them in the chat, and then talk about some of the features that you could help us give feedback. All right, without further ado, let's jump into the release notes. Where is the transition? I feel old already. No one noticed, right?
That worked really well, Alex.
It worked really well, yes. Okay, I'll move over one of my screens. So, first of all, our last sprint was 4 weeks long instead of the usual 3 weeks, and it's because we're focused on improving the quality of Prisma client and the overall developer experience. And some of the notable improvements that we made was, for example, optimistic concurrency control. And optimistic concurrency control is a model that defines how concurrent operations that are being performed on a single entity should be handled. I'll give an example. So let's say both Niko and I are on Amazon, and we'd like to both rent a DVD. Yes, in 2022, we're renting a DVD.
I love these real world scenarios that we're making up here.
Indeed. And let's say that both of us hit the rent button at the same time, and we're in different parts of the world. So since both requests are sent out at the same time, when my request is sent out, we'll see that the records that are available is 1. However, if Niko's request goes through before mine, I'll run into an error. And this is what optimistic concurrency defines. And it defines how you should handle such a use case when you're handling a request. So yeah. The other improvement that we made is precision when working with decimals. And this is something that I have experienced before. And if you had like about 15 decimal values after the decimal point, Prisma client would fail. So hopefully if you're also experiencing that, we fixed it in the last sprint. So take a look, take it for a spin, and let us know if you run into any issues. The other thing that we improved was the handling of big amounts of prepared statement placeholders. And Prisma client was throwing up false errors because sometimes the database has a specific limit of the number of prepared statement placeholders. So yeah, we fixed that, and you will, instead of getting a can't reach the database server, you'll get an P2035 error code instead. Now, if some of your queries were working in 4.3.0 and before you upgrade to 4.4 and they're not working, please let us know, and then we'll definitely take a look at them and fix them as soon as we can. The other big improvement that we made was introducing isolation levels for sequential transaction operations. So in 4.2, we introduced isolation levels for interactive transactions, which is a preview feature. And now in 4.4, you can now get started with it by specifying the option in the second argument when working with transactions. And for those who are unfamiliar, isolation is the I in ACID, and it specifies how a data operation is visible within a transaction. Same case, almost a similar case to the whole renting a DVD on Amazon. So yeah, and finally, or almost finally, is a new error code for handling conflicts or deadlocks within a transaction, which is the P2034 error. And it specifies how you can handle a case when you run into a deadlock. So you could either retry or return an error to the user if you run into such a situation. And besides that, we closed a lot of issues. I'm not sure how many you can count because it's a very, very, very long list.
Yeah, it's really nice to see that work by the engineering team where they're really investing a lot of time into what we call the correctness initiative at the moment, just making sure that the baseline of Prisma client, of Prisma migrate, all of that functionality actually works. Fixing smaller bugs, smaller issues before we move forward with the bigger things that we have on the radar for the next couple of sprints, such as Prisma client extensions that I've talked about on the last stream, or PostJS extension, like Postgres extensions, like PostJS, or multi-schema support. So I think we have a lot of exciting big features in store, but wanted to make sure that kind of the base of Prisma ORM is still working as expected. So that's why we've spent this, in particular this past sprint, on fixing and ironing out a lot of the smaller issues and bugs that people might have experienced with Prisma.
Okay. And with that out of the way, we'll jump into our next section where we'll have our guest Peter to talk about preview databases. And hopefully this time the transition is smoother. Well, that worked, right?
Silky smooth. I don't think it could have been smoother.
Welcome, Peter.
Thank you.
How are you?
Nice to be here. I'm also in Berlin, so we actually could have done this all in the same room, but you know,
missed opportunity.
Yeah.
Yeah.
There'll always be a next time for that, and we could probably organize one of those in the future. Yeah, we could give it a try. Why not? Yes.
Yeah, that'd be awesome.
Yes. And for since you've been a long-time friend of Prisma, we've had you before on the stream. But for folks who don't know you, could you introduce yourself and let them know what you do?
Yeah, so I'm App Factory on Twitter. I'm the co-creator of Redwood.js, and that's where I sort of discovered Prisma. Redwood.js is a framework for JavaScript developers, and we have we communicate with databases, and Prisma is the best choice. Besides that, I'm the CEO of Snaplet. Snaplet gives developers accurate data that they can code against, and databases that they can code against.
Awesome. And we brought you on the stream to talk about preview databases. So what are preview databases? This is something that we presented, and we held a conference last year called Serverless Conf, and I believe Niko talked about the concept of preview databases. So if in a TLDR, how would you introduce the preview database?
So, Niko, jump in if I'm butchering your your presentation skills. Actually, I prepared some stuff here, which maybe makes it easier to explain the concept. So, could I share my screen? Am I going to screw up the smoothness?
No.
Again?
It's only been me who's been doing that. Yeah.
Okay. You go ahead and share your screen. Hopefully this is going to work without you needing to restart your browser. Oh yeah, it looks
tried
good.
it earlier. So
okay, perfect.
Okay,
so
infinite loop. I love it when that happens. Okay, so I'm basing this talk, or what I'm about to present, off what Niko described in his previous talk, and I actually shared the video on my tweet stream, and you should go watch it. So there's a problem when you're using a GitOps style workflow where you have a main branch and every single feature or bug fix is a branch that an individual or a team of developers work in. There's this new thing that happens where you get a preview environment, so you can preview the changes that are happening against your code base in a live environment. And like Netlify and Vercel have introduced these, and I think Render.com has them. Before, we just used to have like a staging environment, a single environment that you could preview your staging code against. The problem is that these preview environments run against a single database. They're not isolated, so it's shared. So any changes you make, whether it's like structural changes, migrations, or data changes, are shared, and it sucks. It's just like you get into these states where you can't do any work because your database is kind of shared. So the solution is to isolate the database. So you have a branch, you have a preview environment that has its own URL, and you have your own database. Isolated. And that's what Snaplet allows you to do now with our new preview environment databases. So I'm going to come down here, and I'm going to show you a demo, and then I'm going to show you some other stuff that we can do with Snaplet. So this
One
is one
question, Peter. Before you jump into the demo, I'm just curious. I think that's a really nice explanation of the problem, and I really like the illustrations there. How do people solve this problem today? You must have talked to a lot of developers or a lot of teams, and is it just pure chaos everywhere and everybody's kind of like trying to take ownership of the database when it suits them, but then the next developer or team is going to complain because now the schema is not adding up for them anymore? So how does this work today? What kind of workarounds have people found? What kind of problems are they running into? I don't know if you can talk about this in a little bit more detail, maybe.
I can only really talk to my own experience as someone who's been a developer for a long time. And usually what happens is there's like this isolation or responsibilities. So like there'll be a person that is responsible for infrastructure, and probably this part as well. And then you are the engineers, and you're operating over here. So you create a branch, goes to the preview environment, and then it gets deployed to staging. So if something breaks here, you kind of have to go to the DevOps person or the infrastructure person and ask them for help, either by resetting the state to production, or whatever your snapshot might have been, or running migrations from scratch. But that's kind of the issue. It's like we as developers don't really control this. It's in someone else's hands. And that's what we're trying to do. We're trying to give you, the individual, the ability to like service your own needs, because this stuff, like these infrastructure things, are not what your job's about. Really, your job is sort of write code, make features and fix bugs. And these things, they don't really matter to your day-to-day, to what you're trying to do day-to-day.
So the big friction point basically is that I, as a developer, I now have to like call out to another department, to another team that's responsible for the infrastructure, and talk to them to just resolve my issue. But I just wanted to kind of quickly preview my feature that I've been working on for the last week, and that like I now was proud to release to staging and like show to our like testing community or whatever. And with your solution, I can do this myself without needing to talk to another team, basically.
Yeah, and like usually, I guess there's like a level of coordination here, so that if you are deploying something that could potentially break staging environment, that you wait for someone else to merge their PR, and so you don't get like these, and then they will merge from main and then make sure that theirs is updated, so that you have these migrations running in sequence. But it's unrealistic to do that effectively. So yeah, we kind of give you the tool in order to do this yourself, or for your team to manage this yourself over here. And yeah, let me show you a demo of how this works. So let me open up my terminal here. All right, I have this example app called Northwind. I'm just going to run yarn dev and show you quickly what that is about. So this is just like a database viewer. There's a table called customers, a bunch of columns with some data inside of it. And someone's going to ask me, as an example, that, I actually realized this is a, one second. I realized this is a database that I've run a migration against already. So this happens also in locally. So I'm developing. If I have a look at my Prisma schema, let's open up here, and I look at my customers table, you'll see there's a facts column in here. If I connect to my local database, because I was busy creating a feature and then I went back to main, my local database is actually now out of sync. So you'll see the facts column is gone. So if I ran like yarn Prisma migrate, I always get confused with these ones, and I run it so often. Oh, because I actually didn't merge that migration. So like Prisma is actually not even picking up that this facts column is gone, but it's gone. I think I need to do like DB pull, right? And then it'll be like, hey, there's something missing here.
I have gotten a little bit lost there, to be honest. Maybe we can start over. So you're showing this demo. You're showing the Northwind example. It's connected to a database that's running locally on your machine as well.
Yeah. So what I'm going to do is I'm going to skip over that part, the bug that I just kind of shown. I'm going to restore a Snaplet snapshot, and then I'm going to sync my database with my Prisma schema. So if I refresh this, you'll see the facts column in here again. This is the one that I removed in a different PR. So let's start from scratch. Okay. I work for the company. They came to me and they said, hey, we actually don't collect fax numbers anymore. Could you remove this from our code base? So I say, yeah, sure. I open up a PR. I create a migration. So I'm just going to go over here and I'm going to open up this branch that I already have. And I've removed the fax column from here. So I commit this, and then I create a PR for this. So I say, okay, I've actually removed the fax column. And if we go and have a look at the demo, you'll see it's gone. Oops. Let's just start that up again. So this is on my local machine, and the facts column is now not there anymore. It is there. So I need to run yarn Prisma migrate dev. All right, it removed the facts column. Oh no.
And now if you run it, then it's removed from that UI here.
So
and that application which you're running locally here is really just representing the current state of your database with all its with all its columns. How are you actually implementing that? Just as a random side question, is that?
It's really simple. It's just fetching the column names from the schema.
Okay.
Fetching all the data.
I see. It's rendering literally what's inside of the database.
Yeah.
All right.
Yeah. So now I have this this migration, and I actually want to create a PR for this. So I say GitHub PR create. I submit the PR, and it opens up in my repo. And Netlify is going to do a deployment preview. So if we go over to Netlify, we can see it running the deployment preview. And it's going to run the migrations and all this other stuff. In the meantime, someone comes to me and they say, "Hey, you're busy working in the customers table. Would you add a Twitter column?" So I say, "Yeah, sure, I'll add a Twitter column, but I want to be a good citizen and I don't want to mix ideas together. So I remove the facts column, or I'm a different developer, and now I'm going to add a Twitter column." So if I go to my schema, you'll see I've added
developer A removed the facts column, developer B now adds the Twitter column, but you're working on your own branches?
Yeah, we're working on our own branches. So I've switched the branch, and now you can see that the facts is still there because I was coding against main. So I've now created this PR.
I can see where this is going.
If I try and sync my database, it's going to fail, obviously, because there's a mismatch. But if I say GitHub PR create, I'm opening up 2 PRs. And if we go look over here, Netlify is going to pick it up. It's going to run the things. This one, let's see if it's finished. Okay, it's still busy. So now we have 2 separate PRs running in Netlify, and they're both creating deployment previews. So if we go and open these up, let's just wait for them to finish. It always feels like things take slightly longer when you're doing a demo, but it's actually just
where is the database hosted at the moment? Where are you actually connecting to?
So these are actually using Fly databases.
Okay.
That is our implementation of preview databases runs on top of Fly.
So it's bound to Fly. If I want to use this with my team, that would mean I need to use fly.io as my database provider as well.
No, you could just use. This is a service that's fully given to you by Snaplet, and I'll explain exactly how that works. But you can just use Snaplet. If you have a Snaplet project, you will have deploy previews. So this one is deployed. This is the branch where we remove the facts column. If I open it up, I go to customers, the facts column is gone. If I go to this one over here, which is adding of the Twitter column. All right, that one's still busy. But essentially what's going to happen is you now have 2 preview databases, one for this PR and one for the second PR. And they're running independently and isolated from one another. If you ran against a single database, you would have had these conflicts and it wouldn't have finished. And you would have had to figure something out. So now if we go to customers, you'll see we have Twitter and it's null. There's no data in there. So how does that work? It's actually kind of, it's fairly straightforward. So when you open up a pull request, Netlify preview deployments or we also have a GitHub action that you can use in Vercel, picks up that you opened up a branch. We then run this command, snaplet db create --git, which gets the current Git branch name and gets the current Snaplet snapshot and creates a database. So if I went like this and I type snaplet db_ls, you'll get a list of databases. Here you can see these are the 2 that I just created. And I can actually grab the URL for that snaplet db URL. I can just paste that in there. I'll delete this later, so the password doesn't matter. So it's just going to spit out a connection string. So this connection string that's related to the branch that we're currently in. So if I type snaplet db url-git, it would look at this branch and it will give me a connection string for that branch. This connection string is injected into your preview deployment environment via a Netlify plugin that we've written. And we have the same thing for Vercel. So we'll create a database for you. We'll create all the schema for you, although you could also use Prisma to do that. We'll inject data into it, and then we'll modify your environmental variable so that the preview environment is completely isolated, so that you get this nice thing. So here's like these two separate databases for you. Whoops. So you get these associated to these preview environments. And this works really well in Netlify, and it worked well in Vercel, but you have to do it outside of Vercel using a GitHub action at the moment. And that's does that kind of like make sense conceptually how these things tie together?
For me, it does. And I have one question, which is, with Vercel, they usually have like you have a preview URL for the entire pull request, and then you also like a URL for each and every build within that pull request. So will Snaplet also handle such a use case where there'll be a build or a database, a preview database associated with each build?
We don't. I mean, we could, but we don't. Yeah, we just use the same one. I'm wondering if we should do that. It seems. And we also know that Vercel doesn't actually, like, if you close a pull request, they'll just keep those preview deployments around forever. And obviously, we don't want to keep the databases around forever. So another thing I wanted to show you, like this database that was created now, if I delete it, it's going to be gone. And if I refresh that page, it's gone forever. But I can also just create it. I can say snaplet db create. I use the name. You can ask me which snapshot I want to use. So this is like a snapshot of my database and the data inside of it. And I'm just going to restore that. This obviously didn't run the migrations, so there might be a problem there. But this is how it works conceptually. It just like creates these databases for you, spits out a URL that it spits into your environment. So you'll probably, get an error with the facts one, because Prisma is going to say, hey, oh, okay, well, it's just empty. Maybe because we're using information schema and not Prisma here. Yeah. Okay. So actually, yeah, that's it, really. So it's this command line tool that we've glued into Netlify and into Vercel and your GitHub style workflow that gives you, as a developer, the ability to manage your own infrastructure and the data inside of it in a really efficient manner. So earlier when I showed you the preview deployment with the Twitter handle, you could use Snaplet to generate Twitter handles, create a snapshot, and restore that into the database as part of your preview deployment. Like, you don't have to use a snapshot from your production database or staging database. You can modify all the data in the stream and restore a snapshot like that.
Okay, pretty cool. And if I'm interested in getting started in my own project, where can I go to learn more? Yeah.
You can go to docs.snaplet.dev. You can go to preview databases. It is experimental at the moment, but it's working really well. And then from this point, you can sort of understand how it works together, how the command line works. And then we have a Netlify plugin in our GitHub using Netlify, and we have a GitHub action if you're using Vercel. And actually, I would really encourage you, if you're interested in using this, just to reach out to us on Discord. If you type Snaplet Discord in our CLI, it will pop up and then you come chat to us. We have a really active and nice community. And we're very interested in making this work for everyone. So
there was some really good validation for the entire idea of preview databases in the comments, I think. So some conversations here like also marking that it's a pure mess, and like never saw anyone getting a really good developer experience with this problem. And then Julien, he somewhat confirmed you can have a good developer experience, but it's a big DevOps job upfront to get there. And it literally took them months to get it right. So if you can solve that for developers and make it easy for them, I think you will have big success with this project.
Yeah, I think earlier today I had messed up some migrations, and I was just using Snaplet snapshot's ability to like move my data and my database around in a fashion that made sense to me as a developer. I think one of the things I hate the most is when I run a migration or I'm switching branches and Prisma says things like, "Hey, sorry, we have to delete all your data." And I'm like, ah. Then I was just like, all right, I'm just going to write Snaplet snapshot restore, get back to whatever main looked like or what the production database looked like, run the migrations against that. And then it feels like I have control. I understand what's happening. It felt really good to use these preview databases. And I actually wanted to explain something earlier. It's like you can use it as a preview database, but you can also, as a team, use it to code against. Like you can just type snaplet db URL --git, you get a URL, and you can actually write your code against that. And then when you open up a preview, pull request, you can use that same database in the preview. Like we won't overwrite it, we won't delete it. We'll just say, okay, the one you actually coded against is the one that your preview is running against.
Okay.
That feels powerful.
It does. And Steven Roth is ready to throw away his RDS multi-database auto creation.
I like that he says that I took months to develop. So it's like, it also took us a while to develop this. So let's suffer together.
Okay, that's pretty cool. Are there any other deployment providers that you also intend to support next, besides Vercel and Netlify?
I suppose it's a GitHub action, and it's the CLI. So any hosting provider that allows you to install a binary or take control of the build pipeline is an easy integration target. I would love to hear if people are like, I need this on mine, we would add it.
Okay, pretty cool. Well, thanks, Peter. That was very insightful. I learned a lot. Niko, I hope you did. Did you?
I did as well. I think that was a fantastic demo and a great explanation. Really enjoyed your Excalidraw skills there. It's such a useful tool to quickly illustrate some technical concepts. That was really nice.
Yeah, thank you for the prior artwork. It helped me clarify my thinking, and thanks for jumping in when I messed up the beginning of the demo.
Oh, good. So Peter, thank you for joining us on this stream, and we'll hope to see you soon. Hope to see you soon. Yeah.
All right. Thanks, Peter.
Bye.
Ciao. Okay. We almost ran into a rest condition or an optimistic concurrency control situation right now. Okay, so we'll jump into our next segment where we'll talk about the Prisma data proxy, what it is, the problems that it solves, and whether you should use it in your project. So I'll go ahead and share my screen. Yep, let me know when you can see it.
Yes, I can see it. And yeah, this page, by the way, we're intending to update it pretty soon. So we're just using it as an illustration, but actually we are going to point out some additional points about the data proxy that are not yet represented on this page. And probably if you open this page next week, I think we want to deploy the new version, maybe even tomorrow or the beginning of next week. There will be some changes to make the value proposition of the data proxy really more clear. So the big topic, I think, is the topic of connection pooling when we talk about the data proxy. It's one of the core problems that it's supposed to solve. And we've built the data proxy because a lot of developers have talked to us that we're using the Prisma ORM, specifically Prisma client, inside of serverless functions. And if you know how serverless functions work, and if you know how traditional databases such as Postgres and MySQL that Prisma supports work, then you know that there is a mismatch in the models of the two. So the model of a traditional database is that you have to connect to it using a TCP connection. A TCP connection is a long-running connection that's established between two computers, really. And this connection is then used to send queries back and forth. So an example would be I'm building an API server. Maybe it's hosted on Heroku. I also have a database, a Postgres database that's also hosted on Heroku. And now I have an endpoint, something like create user or sign up, where I'm supposed to create a new user record in the database. Now, let's say I receive 10 requests to create new users in parallel. Then my application code, it will create a connection to the database, or depending on how it's implemented, actually, it can also implement multiple connections. But let's start with a kind of naive approach here, where we would say that there is one database connection between the API server and the Postgres database, and I have 10 incoming requests. Well, what would happen is that this one connection, it has to, it can only serve one request at a time. So I'll send one query to create a new user record over that connection. And then I send the next query and the next query and the next query, and that would take quite a long time. So I can improve that by having multiple connections that I can use for all of these different requests. So let's say I have 10 connections open to the database at the same point in time. Then it means I can serve all of these 10 requests in parallel. Now, another issue with database connections is that they're not free to create and they're not free to close. So in fact, what you want to do when you have a server, a long-running server hosted on a platform like Heroku, is you want to keep your database connections open so that you can reuse them whenever a request is coming in. Otherwise, if they would get closed after they had been served a request, you would have to reopen them with a new request. And that's what you use the concept of a connection pool for. So the connection pool is basically a set of connections that my application server is keeping open for me, and it can then assign incoming requests to the open connections that are currently idle, so that all my requests can be served at the same time. Now, what happens if I still have these 10 connections open? I have a connection pool of 10 connections, and I receive 100 requests in parallel. Well, if I didn't have the connection pool, it would be a problem. But with the connection pool, I can just wait to assign the new request to a connection that has been empty. So that's the problem of connection pooling in general with long-running servers, where you where you want to use this. But then it gets even worse in the context of a serverless function. When you're using a serverless function to access a database, then the serverless function, it really gets spawned for a single request, and then it creates a connection to the database, and then the function is being frozen afterwards, and that connection can't be reused. It stays open. And now if you receive 100 requests in parallel, you'll run into the problem where you will spin up 100 instances of your serverless function. And in each of these instances, you're now creating its own database connection to the database to serve the request ultimately. The problem here is that most databases come with a connection limit. They cannot just create new connections indefinitely, but you'll probably have a connection limit configured in the realm of, depending on like how your application actually needs to scale, can be 5 connections, can be 10 connections, can be 100 connections. It really depends on your individual application, but there is a limit. And that's the important point. So if you're running a serverless function and you have a traffic spike and you get a lot of requests in parallel, then your database ultimately is going to run out of database connections, and some of these requests that have been coming in parallel will actually fail because the serverless function is not able to serve the database anymore. And that's why you want to introduce an external connection pool in between the database and the serverless function, so that the serverless function can actually connect to that external connection pool. It can grab a connection from there and then serve the request against, or serve the query against the database. So this problem of connection pooling is one of the main features that's solved when we're talking about the data proxy. You don't have to use the data proxy to do connection pooling. So of course, there are other tools out there that will enable you to do this, such as PG Bouncer, or some AWS solution as well. I think RDS Proxy is another one. So really depends on your setup, on your infrastructure and your preferences, which solution you can use there.
Interesting. I just had a random question that popped up in my mind as you're talking about the challenges when managing a connection pool. And is it possible to run out of connections when you're working in a serverful environment? Let's say you've deployed the application to Fly, and yes, you have a limit of 20 connections, and and you receive, let's say, 1,000 requests. Is there a possibility of running out of connections in such an instance?
I think that would depend on the configuration of your connection pool and on the timeout that you've configured for your HTTP requests that are incoming. So in theory, if all of these requests are being served quickly enough one after another, and the HTTP requests can wait until they send the responses back to their clients, I think in that case, everything should be fine. But if your HTTP request timeout is configured like fairly low, and the request has to wait too long for an idle database connection to be served, then I think it can still happen that your HTTP requests still fail.
Okay, cool. The other value proposition that, the data proxy offers is that you're able to access a database from the edge or edge environments. And edge environments are environments that allow you to run your application or server-side application code as geographically close as possible to your user. Examples of these platforms include these Cloudflare Workers, there's Vercel's Edge Network, I believe. And I'm not sure if Netlify has one, but I think they have edge functions or a similar concept. For you to be able to run your application code as geographically close as possible, the moment you deploy application, it's instantly available in all your data centers. You kind of have to make like a trade-off, and this is where edge environments are kind of smaller, and they only allow HTTP-based requests, and also the size of your application kind of has to be kind of smaller than the usual serverful environments. So again, the challenge here becomes that you can't access a traditional database because you require a TCP connection, which most traditional databases require. And one way to get around this is by using the data proxy, and it allows you to interact with the database over HTTP, and you can interact with your database from any edge network. The downside, however, is that with most database providers, most deployments are usually single region, and with the edge network being global, sometimes your request or the response times might take longer because the database becomes your bottleneck. We created an article and a video on working with the database on the edge, and Niko shared it in the chat. Feel free to take a look at it whenever you can. Yeah. What's the other value that the data proxy provides? Yeah.
So the last benefit, and I think that's also a really important one, if you are using Prisma client in serverless functions and you're not aware of the data proxy, You might have seen an issue with the bundle size inside of your serverless functions. A bigger bundle size of the bundle that you upload to the function can contribute to a slower startup time of your function. And with Prisma Client, what happens actually is that, with the Prisma Data Proxy, when you're using that, what happens is that not only the connection pool lives on the data proxy, but also the query engine that's usually used by Prisma Client to like, for example, generate SQL queries under the hood. That's usually happening in your node environment where you're running your application. With the data proxy, that query engine moves to the data proxy infrastructure component as well, so that you have a really lightweight application bundle now that will lead to a faster startup time of your serverless function.
Okay, interesting. And I think Internet has a question, and it's if I'm on MongoDB, why should I use Prisma over the native drivers? I'm not sure if this is related to when you're working with the data proxy.
I think I think it's a general question that we maybe want to pick up at the end when we pick up questions.
No problem. Race conditions. Okay. With that out of the way, I don't know. I don't have any other questions about the data proxy. Well, stay tuned and look at the page. And if you have any questions about what it is and how it does, what it does, let us know. Yeah. So we'll now move on to the next segment where we'll talk about the article series that I have been working on. It's getting smoother. I think it's getting smoother. So yeah, over the last 1.5 months, I have been working on an article series on improving query performance with indexes and Prisma. And this one is near and dear to me because it took a lot of kind of soul searching to understand what a database really is, because people say it's just a key value pair store, but then what is it? It still doesn't. On a high level, it might make sense, but I dove a little deeper into the fundamentals and to understand the problem that it solves. So is that big enough? I'm not sure if the view is large enough.
Yes.
Good.
That should be readable.
Yeah. So far we have 2 articles in the series out of 4, and in the first article I walked through the fundamentals of database indexes and the problem that it solves. And on a high level, the problem that we're solving is ensuring that we're able to retrieve our data from a database as fast as possible, I believe, or minimizing response times. And I'm not sure if I should give out too much, but I use the analogy of a library where you have a lot of books, but you kind of have to come up with a strategy of how you want to get a book from a certain shelf as fast as possible. And some of the strategies that you could use is, for example, instead of having one gigantic shelf and storing all the books inside it, is that you can store the books in smaller shelves, which we would call partitioning. So meaning that whenever you are retrieving a book, you already know what shelf it belongs to, instead of having to go through the entire shelf. So you just go through that one tiny shelf. The other strategy that you could improve performance is by query parallelization. And in the analogy, well, going along with the analogy of a library, it would be asking for help from other librarians in order to get the books faster, because they already have the knowledge or the resources where things are stored. And in the context of a database, you can assign more memory, more CPU in order to fetch more books, which definitely improves the query performance. And then the final strategy is by using a catalog in a library. And this is just a way of storing the metadata about the books. And you just keep like a snapshot of snippet of the book's details, so that you already know the book's details, so it just leads to where the book is stored. So yeah, that was the first article. I also covered the different types of database indexes and how databases, for example, fetch data. And for example, there's a sequential scan. I'm not sure if this is the right snippet. So there's the sequential scan where the database query, when you submit a query to the database can decide to just look through each and every record one at a time before it finds a record. There's also
the sequential scan is really what you want to avoid when you have a lot of rows, right? Because that means that the database really has to search through maybe 1 million of rows, and it can become really slow like that.
And the bigger the data set, the longer that it might take you to find a record. Databases, I should say that most databases have implemented some sort of caching strategy, which kind of improves its own performance at the database level. There's also an index scan where instead of going through the entire table, the database can go through the metadata or the catalog instead, and then it finds, because it's definitely smaller than the table in terms of is it width? It's identical in length but smaller in width. So instead of storing the entire content of the book, you store, for example, the content of the title, the author, and maybe ISBN number. This probably shows how much I read as well. Yeah. So you just have that and you go through that catalog and then you find where it is, and then you kind of consult, you use that data to now find where the record is stored in the exact table, and that's called an index scan. And in the event you don't need the book itself, or in this case, the rest of the data, and all the data you need is contained in the index, the database might not have to consult the database. And this kind of scan is called an index-only scan. The other kinds of index scans, the other kinds of scans like bitmap heap scan and the index scan, which I think it uses like a bitwise operator. So the data, when it's scanning the indexes, it either, I think, responds with a 1 or a 0, which is a bit, I guess. Which is faster. Yeah, that's just a bit of, if you do have the time, I encourage you to dive into the different ways that the database scans data, because it's interesting, it's fascinating, especially Postgres out of the main providers. However, the cost of indexes is that it comes at a cost, and this means because the database requires, for example, more storage and more memory to maintain these indexes. So a general rule of thumb is that use it sparingly and only use it on columns that you query them frequently. Yes. In case you're interested in diving into the entire article, it's all inside here. And in the second article, there are also nice illustrations that took time to create, like this on partitions. Yeah, it was pretty fun trying to create and also visualizing how the database works. In the second one, we talked about B-tree indexes, and this is where I kind of I learned to appreciate the computer science class that I wish I had, I guess, because the data structure that is used by the database. So a B-tree is a special kind of data structure which is kind of built on top of a binary tree. And a binary tree is a kind of tree where it's divided, it only has two children, the right and the left node. And I'm not sure how, I don't think binary automatically sorts the data. However, for B-tree indexes, it's special because on every insert, update, and delete, the data inside the entire tree is rebalanced, and by rebalance, being reordered into the position that it belongs. There's a nice illustration that I included. I
remember from my university when we were taught algorithms and data structures, the differences between the binary tree and the balancing binary tree, and exam questions of, okay, you have to add this node to the tree, walk through the algorithm of appending this node, and then rebalancing the tree, things like this. So that's basically like how these binary trees work.
So in case you're interested in learning the different data structures, it's fun because if it's your first time and you're not doing it in class, it's mind bending in some way, trying to wrap around these concepts inside your mind. And they have their own value, like in database indexes. Yeah, so definitely take a look at the data structures and as well as the article itself. So yeah, I'll share a link to the series. Stay tuned for more. There'll be one on hash indexes and gin indexes for Postgres, which will be coming out at a later date. And I do have a little demo, but I'll have to redefine the screen that I'm supposed to share. Yeah, actually, so give me a moment to do that. Share screen. Yes. Can you all see the screen?
Yes, it's there.
Cool. So this is the demo project that is used in the B-tree index article. It's a fairly simple REST API with a single endpoint. I'll minimize that. Fairly simple REST API with a single endpoint, which is users, and it takes a fast name query parameter. And the query parameter is used to filter out users by their first name, and then pass down the filter using Prisma, and then Prisma responds with the data. I already went ahead and applied a migration, and the migration only defined the table inside the database. And there's only one table, which is user, with the primary key set to ID and what is defined inside the Prisma schema. It's fairly simple, fairly straightforward, a single model called user with an ID, first name, last name, and email. I also have a seeds.ts file, and in this file, I was using Faker to seed the database with about 500,000 records, as you can see here. And yeah, and then on every time I seed the database, I delete all the users and then recreate the data as well. So next thing, I have a which file is it? A request.http file. I'm not sure why it's during demos when things kind of decide to be invisible somehow, or it becomes harder to find them. So inside the request.http, I have a couple of HTTP requests, and I'm using the REST client HTTP to make the requests. And it just makes the request to the endpoint that we defined inside the index.ts file. So I'll go ahead and start the server. I'm not sure if it's running since I have two terminals. It's not. So npm run dev. And the server should start. Fingers crossed. So I'll go ahead and make a sample request here, and we'll see that the request took 525 milliseconds to respond for Prisma to return the data, and it returns all the data whose first name is Jane. There's also Nicholas, which took 915. Wow, that's longer than I expected it to be. It should have been in the 200 millisecond range. And then there's also Cole, that's 682. And we can already see, oh, that was Mary. And Cole took 737 milliseconds. So yeah, I should have done a count of how many records were there, but definitely this looks like it was definitely big if it got to 1190 lines. So the query response times are fairly slow. And one way that we can improve this is by defining an index on a query, on a column that you query frequently. And one way you can define an index is on your Prisma schema file. You can add the at index attribute. And then you have the fields. And then you can specify the fields that you want to index. And in this case, we want to index the first name. Then back on my terminal, I'll create another migration. dev-n add index. This should take a moment. Applying a migration, and it's done. So it created a new migration inside the migrations folder. And as you can see, it's applied on the first name field with the name user first IDX. You can define your own index name inside the at index attribute. So if we restart the server, give me a moment to, or I think it should still work, but I'll go ahead and restart the server. Then back in the request.http file, if I make another request, you can see that it took 23 milliseconds, and last time it took about 935 milliseconds. I assumed that was a cold start from Prisma. It turns out, but it was kind of fairly consistent with the other queries. And if I go ahead and query Nicholas, you can see that it now takes 18 milliseconds, which is significantly faster. And if I request for Mary, it took 9 milliseconds over here. And if I request for Cole, it's 20 milliseconds. And you can definitely see the significant jump in performance with just adding an index to a in your model. Yes. Cool. And
So
that
nice.
was the demo. Yeah.
Super insightful. I really like this. And I'm also very much looking forward to the next articles that you're going to publish in this series. I think it's really insightful, especially for people that maybe have less experience with database indexes or don't know so much about database performance so far. So I think that's going to be really valuable for these people.
Indeed.
All right, we're at the hour, so I think we can wrap up with some plugs that you have prepared.
Yeah, we also had a few questions in the chat, by the way.
All right, okay, yeah,
yes.
we should pick up the question with MongoDB, and I'm happy to take that. And like, to be honest, I think the main reason to use Prisma, especially over native drivers and not even Mongoose, is just the developer experience that you get with Prisma. And developer experience in particular with respect to two factors, and that's data modeling and querying. The data modeling part in particular, I think, can be really helpful to just understand the structures that you actually intend to store in your MongoDB database. And then, of course, the type safety aspect of it, where Prisma actually makes sure that the documents that you're storing inside of your collections adhere to the structure that you intend to store. So I've heard of a lot of horror stories before where MongoDB users in plain JavaScript without extra schema validation just kind of lose track of the structure, the exact structure of the objects that are stored inside of their database. And that can lead to really, really troublesome scenarios later down the line. So the type safety and the fact that you can model your data easily, I think, are huge benefits that you get with Prisma. and then the intuitive querying that you get with Prisma Client. Although, to be fair, I think the native Mongo querying API also isn't too bad. But for example, it won't really give you any auto-completion for the properties of the objects that you want to store. So I think that there are still a lot of benefits to Prisma in general.
And Sabine is iterating on what you said with schema-less means no data structure. Very important. Yeah.
Yes.
We also had a question from Sivan Rot. I hope I'm saying his name right. And do we have any metrics on how much it reduces the bundle size? I think
so,
this was.
We don't have any concrete metrics. I think it also always depends on the size of your schema. But in general, the Prisma query engine usually is a couple of megabytes. It can be up to 20, 30, 40 megabytes. And that's a lot. And that's just what you get rid of when you're using the data proxy, because then that query engine is moved to the data proxy, and the bundle that you're uploading to your serverless functions will be a lot smaller. So you can be sure to at least save a couple of gigabytes when you're using the data proxy.
Cool. And I think this is the final question, is whether we can use multi-column indexes as well. Well, yes, we can use multi-column indexes, but it depends on the index that you're working with. Specifically, for example, hash indexes doesn't support being applied on multiple columns. But with B-trees and gin and the rest, it should be possible. Yes. Cool. And moving on to the plugs, I'll re-add my screen to the stream. So give me a moment to copy the link. So the first one is that we recently released a preview feature, which is the multi-schema that allows you to work with multiple schemas within the database. It's still in very, very early preview. So in case you'd like to give it a try, feel free, give it a spin, and let us know what you think about it. Yeah. We'll be making improvements to it soon. We'll hopefully integrate like migration and integration support in the near future. So keep your eye on that. The other note is that we are hiring careers. So in case you're interested in work with us, either joining the developer advocacy team, like Niko and I join us on this stream, that is, or you'd like to help build the open source tools or our commercial product, we have a couple of open jobs, and we encourage you to apply. And you get all the perks that you would get in a tech startup, I believe. And I think my favorite benefit out of all that is the mental health days, which allows you to just take time to yourself and recharge every once in a while. Yeah. Are there any benefits that you enjoy out of all that we offer, Niko?
I guess the chair is pretty cool, although I'm like using it to have a chair here in my home office without even the like, what do you call this? Like the back, like where you can like lean your back.
Okay.
Back lean thing.
What's it called? Yeah, the backrest. I think let's just call it backrest for the rest of the episode. Yeah.
All right.
Yeah, and finally, in case you've been on our community Slack, you might have noticed that we made a couple of changes, and we have been revamping to help improve the whole experience whenever you ask a question. And we renamed a couple of channels. We added descriptions, which should help clear things. So if you let us know what you think, we'd appreciate your feedback as well. Yeah. Which also reminds me, perhaps we should add like a CLI tool that Snaplet does, npx Prisma Slack, and then opens up Slack, and then yeah, could be pretty cool. Yeah. And that's about it. Well, I shouldn't have shown that screen. that's all for today, folks. Thank you for joining us, and we'll see you on the next one.
Thanks, everyone.